This lesson is about the indeterminate forms. At the end of this lesson, you should be able to apply properly the use of L'Hopital's rule in evaluating limits of rational functions that initially would result to either a 0 divided by 0 or an infinity over infinity form. Let us now look at the different kinds of indeterminate forms. We have the primary forms, the 0 divided by 0, and the infinity over infinity, and the secondary forms of 0 times infinity and infinity minus infinity. If we are given a rational function and we are asked to evaluate the limit of this ratio as x approaches a, and the result is an indeterminate form, either a 0 over 0 or an infinity over infinity, then the limit can be evaluated using L'Hopital's rule. Here, we consider the limit of f of x divided by g of x as x approaches a to be either a 0 divided by 0 or an infinity over infinity. Now, as such, the limit can be evaluated using or applying L'Hopital's rule. The rule simply states that if the limit of f of x as x approaches a is 0, and that the limit of g of x as x approaches a is also equal to 0, or we have the case of the limit of f of x as x approaches a increases without bound approaching positive infinity, and that the limit of g of x as x approaches a also will be approaching positive infinity, then the limit of the original ratio f of x divided by g of x as x approaches a can be evaluated using or in terms of the limit of f prime of x divided by g prime of x as x approaches a. And if there is a limit to this particular ratio, then that will also be the limit of f of x divided by g of x as x approaches a. So, given a rational function, if the resulting limit initially is of the form 0 over 0 or infinity over infinity, we can make use of L'Hopital's rule. And the following are the steps that we need to do applying L'Hopital's rule. First is, we check whether the limit of f of x divided by g of x is an indeterminate form either of the 0 over 0 or the infinity over infinity form. Having verified that we have an indeterminate form of either of these two forms here, then what we do is we differentiate f of x and g of x separately. And we now evaluate the limit of f prime of x divided by g prime of x as x approaches a. And if there is a limit to this ratio, then that is the limit of the original expression. Okay, let us illustrate the use of L'Hopital's rule, working on some examples. So for number 1, we want to evaluate the limit of sine 2x divided by 2x as x approaches 0. Initially, when you investigate what the limit of this ratio is as x approaches 0, then this will simply give you sine of 2 times 0 divided by 2 times 0, or we have 0 divided by 0. Recall from the introduction that we have before we started our discussion on the derivatives, we reviewed about limits. Okay, so applying the rules that were given there, the limit of sine 2x divided by 2x as x approaches 0 would be of the indeterminate form 0 divided by 0. Okay, as such, we can apply L'Hopital's rule to evaluate the limit. And that, we simply will have to evaluate the limit as x approaches 0 of the ratio of the derivative of the numerator sine of 2x to the derivative of the denominator 2x. Please take note that you differentiate separately the numerator from the denominator and that you do not differentiate this as a ratio. So if we will now continue differentiating on sine of 2x with respect to x, the derivative, if you recall, will just be equal to cosine of 2x times 2. Following the rule, differentiating a sine u, that would give us a cosine u du dx. Now, as to the factor 2x, its derivative with respect to x would just be a 2. This now is the limit of f prime of x to g prime of x as x approaches 0. And if we try to evaluate the limit, then we will just have here the limit equal to cosine of 2 times 0, or simply we have cosine of 0, or that is equal to 1. Now let us look at another example. Here we evaluate the limit of x squared divided by e to the x as x approaches positive infinity. So when x increases without bound, x squared likewise would be increasing without bound. Okay? And it's even increasing faster than x. Now, e to the x, when x increases without bound, getting more positive, would also be increasing and getting more positive. So here, what we have for the limit, now if we will be investigating initially what the limit is, then it is of the indeterminate form infinity divided by infinity. Now, this is the other form of the indeterminate form falling under the primary forms. Okay, and because the limit is an infinity over infinity, we can now apply L'Hopital's rule to evaluate the limit of the set expression. And by applying L'Hopital's rule, we try to work on the limit as x approaches positive infinity of the ratio of the derivative of x squared to the derivative of e to the x. Now, differentiating each of these, we will just have a 2x and an e to the x. And if we try to evaluate the limit of this new expression as x increases without bound, still we observe the limit to be of the indeterminate form infinity divided by infinity. Now, please take note that L'Hopital's rule can be applied provided the limit of the ratio is either a 0 divided by 0 or an infinity over infinity. So based on this result, we can apply L'Hopital's rule to evaluate the limit of the said expression. So the second application of L'Hopital's rule, evaluating the limit of the given fraction here, would be undertaken as follows. Evaluate the limit as x approaches positive infinity of the derivative of 2x to the derivative of e to the x, where in the numerator we just have a 2 and the derivative of e to the x is e to the x. Now we have this new fraction now. We try to investigate what the limit would be as x approaches positive infinity, and that limit will be in terms of 2 divided by something that increases without bound. This ratio value will be decreasing and decreasing as x increases, and therefore this ratio will be approaching 0. 0 is the limit of 2 divided by e to the x as x approaches positive infinity, and by L'Hopital's rule is also the limit of 2x divided by e to the x as x approaches positive infinity, and by L'Hopital's rule again is the limit of x squared divided by e to the x as x approaches positive infinity. So in conclusion, the limit of x squared divided by e to the x as x approaches positive infinity would be equal to 0. Summarizing on what we have in this lesson, that whenever we are given a ratio or a fraction of the function f of x divided by g of x, whose limit as x approaches a would be a 0 over 0 or an infinity over infinity, then the set limit can be evaluated indirectly by applying L'Hopital's rule, where the rule states that the limit of f of x divided by g of x as x approaches a would be given by the limit of f prime of x divided by g prime of x as x approaches a whenever this limit exists.